Hi guys, today we'll be going over differentiation, and differentiation is a way in which you can find the exact gradient of a curve at a given point. So say you have a curve called y is equal to f of x, and you have two coordinates on the x-axis, x and x plus h, where h is just a very small number. So what Isaac Newton did was he figured out that if you have two x coordinates and they're really close together, the gradient between these two coordinates on a curve is essentially a straight line, and he used this to then figure out how to differentiate, which makes our lives much easier. So you know that the equation of a gradient is the change in y over the change in x. So look at these two coordinates here, x and x plus h. What would the y coordinates be? So for x, the y coordinate is just f of x. For x plus h, the y coordinate is f of x plus h. Now you can just plug this into here, and let me show you how. So essentially, the gradient function, so the expression which gives us m, which we write as f prime of x, this is equal to, and this here is some new notation, I'll explain in a minute, the limit as h approaches 0 of the change in y, which is just f of x plus h, minus f of x all over x plus h minus x, and x plus h minus x just simplifies down to h, so I'll just write h. And this is essentially the expression which you need to memorize to find the derivative, and by the method of first principles. So the limit as h approaches 0, this essentially means when h becomes infinitesimally small and just becomes 0, so you just delete h essentially. It'll make much more sense when we go through an example, and I'll do one next. Let's do this example. Find the derivative of x cubed by first principles. We know that f prime of x is the limit as h approaches 0 of f of x plus h, take away f of x all over h. So all we do is substitute in our f of x, so x plus h into x cubed, that's x plus h cubed, take away f of x, which is just x cubed, all over h. And this then gives us the limit as h approaches 0 of x cubed plus 3x squared h, add 3x h squared, add h squared, take away x cubed, all over h. And this simplifies down to the limit as h approaches 0 of 3x squared h, add 3x h squared, add h squared, h cubed, sorry. The x cubed and the minus x cubed in the previous line just cancel out and leave you with this. And now, if you go up here, the h just divides through, and you're left with the limit as h approaches 0 of 3x squared, add 3xh, add h squared. And now this is the good bit. The limit as h approaches 0 means as h gets infinitesimally small and moves towards 0, so all you do is substitute substitute 0 into h, and you're left with 3x squared, add 3x times 0, add 0 squared, which is 3x squared. Therefore, f prime of x is equal to 3x squared, and this is your gradient function. So the gradient function of the curve is 3x squared, as we just did, of the curve f of x is equal to x cubed. So if I were to ask you, find the gradient of the curve x cubed when x is equal to 2, so what would you do? First you would differentiate f of x, and we just did that by first principles, and we got f prime of x is equal to 3x squared. So now when x is 2, all you would do is substitute 2 into the gradient function, which then gives you 12. Therefore, the gradient of the curve x cubed at the point x is equal to 2 is 12. And this is essentially how you use the gradient function.